And welcome again. You can see one more simple problem, and this is also related to water pressure, hydrostatic pressure. I have written it, and this is a simple problem once again. Uh, a vertical shaft, because in this fluid thing, there is one problem, one kind of thing that is of more importance, and that is the surface tension part. Otherwise, all other things are quite simple. If anything is different, that is the solution of a differential equation, and we will talk about it later. The problem is a vertical shaft fixed in a plane, okay, has a cross section of A1 and A2, and the shaft contains two pistons. You can say these two pistons, and a liquid of density rho. This is a real engineering problem. And the fluid of density rho between them. The pistons are connected by a rigid rod of length L, and the mass of the pistons and the rod is negligible. That's one good thing. And the external air pressure is P naught. That is, if you want to call it atmospheric pressure, you can call it. What is the magnitude and direction of the force acting on the rod if the shaft rests on a horizontal surface? And that is an engineering problem. In the first case, in the narrower, and second in the wider. Oh, narrower, that means shaft is here, and in the first condition it will be like this, and the second condition it will be like this. Don't go on the statement of the problem. There are two situations, and we need to find the tension produced in the rod. So we are going to solve it simply. We don't need to think much. It's a problem of statics. So we should go and keep in mind that consider anything, but net force on it should be equal to 0. So in the first case, in the first case, that is part A of the problem, I would like to consider that water pressure is at the upper piston. Here it's simply P. Here the pressure is P, and I assumed, there is nothing wrong to assume that, I assume that the rod pulls the upper piston downwards with a force something called T, or if you want to write it, give it another name, you can give it. And so it will pull the left. This is Newton's third law of motion, and I would like to write the basic equation of dynamics of upper piston, that is in equilibrium, and that will be only one force from below, that will be the water pressure force, and that will simply be written as PA1, because the area of cross section of the piston is A1 here, and the two forces back to back downward. The another force is the atmospheric pressure force, and that is P naught A1, and the second one is the tension, and that will be equal to 0. All forces acting on it is equal to 0, and I would like simply write for the lower piston this one, and here one pressure force is, this pressure is definitely P naught plus rho is the density of the liquid, GL. L is the length of the rod. So multiplied by its area of cross section, that is pressure force acting here downward, and atmospheric pressure here, and a tension in the upward direction. So I can write it like P plus rho GL A2, that is a water pressure force, minus atmospheric pressure force P naught A2, and minus tension, that is equal to 0. And nothing else. Now we can subtract and give it equation 1, 2, and subtract equation 1 from 2. 2 minus 1, do it 2 minus 1, and you will get the value of P, that is only unknown. And how can we do this? We will have P, it will be something like, if I put P A1 minus A2, 1 from 2, A1 minus A2, and yeah, I can write this, but I would simply like to write the value of P, and I will get something like rho GL by A1 minus A2 multiplied by A2 plus P naught. This is the pressure force, but we haven't found the value of tension yet. So to find the tension, you can put this value of P in any of the equations. Suppose that you put this value of P into equation 1, then you will get going to get T equals P A1 minus P naught A1, and just put the value of P here, and you will get your value rho GL A1 A2 divided by A1 minus A2, and that is the tension in the first case. And in the same manner, you can consider the tension in the second case as well, the case B. And in this case, I think in this case, if you think the same thing, like you put the direction of tension in the same direction, in the same manner, I got something like tension equals minus rho GL A1 A2 divided by A1 minus A2. So A1 is greater than A2. That means this thing is negative. And since it is not and tension is negative here, that means, and this is not a string, this was a rod. So tension becomes negative, that means it doesn't have any meaning at all, is wrong. Because since tension is 0, that means actually a compressive force acting on the rod is getting compressed, and that's, in this case, rod is getting compressed. In the first case, rod was getting pulled, and whatever will be good for you, you should know how to do in the real conditions if you make designs, engineering designs like this. So rest of the things, go and study in an engineering college, not from me. Thank you very much for watching.